And so let's for the sake of this example, oh, I don't know. Let's just do the use the normal distribution with mean mu and variance given. So we're going to have unknown value of mu. So in other words, we're saying that mu can be any value from negative infinity to positive infinity. But we're going to have a known value of sigma squared. Let's keep it simple here and just and make it 16. So our population standard deviation is equal to 4. So let's calculate the MLE of mu. In other words, what value of mu is most likely given our data. And let's keep it short, sweet, and simple here. Let's say that we have a measure, I don't know, of 100. Let's say we have another measure of whatever. So given this data, again, let's choose a value for mu. So let's just for the illustration, let's calculate the likelihood given, for a population mean of 102. So essentially what we're doing here, if we look at the normal distribution, and of course the mean of the normal distribution will reside in the center. So we have these things called densities. So if I can come to 100, and then 105 would be about right here someplace, and 108 would be about right here. The height of this segment from the horizontal axis up to the curve is called the density. So I can calculate the density of 100 by using R, and I'll illustrate that in just a second. Most importantly, the likelihood will be the product of the densities. Now let me get out of here and show you how we can do this in R, and then I want to illustrate it otherwise. So move into R. So what I would do first, I use the function in R. It's called dnorm. Helps to spell it correctly. And the form that dnorm uses is it uses the value you're finding the density at. So ours is, first one is 100. Then we use the mean. We are hypothesizing, but proposing a mu of 102. And then the standard deviation, not the variance, standard deviation. I'm going to repeat that for the second. So the second data point was 105, right? And then I want to propose, 108 is the third data point. Again, proposed mean of 102, standard deviation of 4. So the likelihood that this data came from a normal distribution with given variance 16 with a mean of 102 would be 0.0002, 0.000215 actually. Now let's go back and talk about how this is found without R. Probability mass function for the normal distribution would be is that clear or not clear? I don't know. Let's see. Yeah, it's better. Having a lot of trouble with this screen today for some reason. So this is one that you'll want to tattoo to the brain. So what I could do for the first data point, again, the first data point was 100, so I would have 1 over sigma. Well, we know that now, don't we? 4 square root of 2 pi e to the minus 0.5. X in this case is 100. Proposed mean is 102. Standard deviation is 4. Then we would multiply 1 over 4 square root of 2 pi e to the negative 0.5. Next data point was 10, what was it? 105, I believe. Times the next data point. Put this in your calculator or however. I get for the first term, I get 0.088, and I get 0.075 for the next term, and I get 0.032, which is approximately 0.000212, which is very, very, very close to what we got in R. So, ladies and gentlemen, summary. You should know for first of all, the difference between probability and likelihood. Secondly, you should be able to determine the likelihood of either type of distribution given given data, and then giving kind of a proposed value for a parameter. So. All right, we're done. That's all for this video. Take care.